Welcome. In this session, we'll start with the nomenclature used in discrete time systems. Let's start. So, before I discuss the different nomenclatures used in discrete time systems, let's start with the general nth order difference equation that's used to represent a discrete time system. So, let's suppose we have a nth order difference equation that's given like this. So, an y of n minus capital N is equal to b naught x of n b1 x of n minus 1 plus so on bm x of n minus 1, right? And we are assuming that n is greater than m, so we say this is an nth order differential difference equation. Nth order difference equation, right? If n is greater than, this forms an nth order difference equation. If m is greater than n, then this is an mth order difference equation. All right. Now, what's the difference equation again? Difference equations are used to characterize a this discrete time system. Same way the differential equation describes a continuous time system, difference equation describes a this difference equation describes this discrete time system. All right. This is sometimes also referred as a recursive system in mathematics nomenclature. This is also called a recursive system, where the output depends upon its past values. When the present output depends upon its past value, this is referred as a recursive system. All right. Now, there are different names that we can obtain for this discrete time system based on this difference equation. Now, before we do that, let me rewrite this difference equation first, and we'll assume either a naught is equal to 1, or what we will do, if this is not the case, we'll divide every these coefficient, coefficient by on both sides by a naught, so that the coefficient of y of n becomes 1. That's that. If this is not the case, if a naught is not equal to 1, then divide every quotient by this a naught. All right. So here we'll assume it's equal to 1. So we'll rewrite this difference equation like this. Is equal to b naught x of n b1 x of n minus 1 b2 n minus 2 plus on bm x of n minus n. So this is our difference equation, and we can also write it as like this. We can also write it as like this, y of n plus k is equal to 1 to n a k y of n minus k is equal to summation k running from 1 to m bk x of n minus k. So we can also write it in the summation form, right? So this is the difference equation. Now the first name for this difference equation is moving averaging system. We can say this becomes a moving averaging system or moving averaging filter. Now remember, every discrete time system is a filter actually. So whether I say from this point onwards a discrete time filter or a discrete time system, this means one and the same thing. So a discrete time system is also called as a filter. So you can say this is a discrete time system, moving averaging system or moving averaging filter, right? Now this is the system, this is a discrete time system whose output means y of n is dependent on the present and previous inputs, on present and previous inputs. So this is referred as a moving averaging system or moving averaging filter. Now what do I mean? This means simply this term will be zero. So this means this term will be zero, means y of n is a function of only the present and the previous inputs only, not the outputs. So So this is the moving averaging system. Now the what does this averaging mean here? Now the averaging comes from these coefficients. Means these are weighted averages. Means these on these coefficients B0, B1, B2, so on up to weighted averages. So these are actually weighted averages. And what do I mean by weighted averages? Because the name of the system is moving averaging system. So you are doing some kind of an averaging. And the averaging happens here in terms of these inputs, present and the past inputs. Right? So let me give an example. Now the example of this system, the averaging system is like this: x of n plus x of n minus 1 plus x of n minus 2 and whole divided. So this is a moving averaging filter or moving averaging system where the coefficients B0 is 1 by 3, B1 is 1 by 3, B2 is 1 by 3 and rest of the coefficients are 0. You can compare this with this expression. You can say this is a moving averaging system. This is a moving averaging system. Here the order is M. So here the order is M. And the order of this differentiation is M. Alright. So how many coefficients do we have here? We have m plus 1 coefficients. You can see there are m plus 1 coefficients. There are m plus 1 coefficients. And in this example, we have 3 coefficients. This is very important for weight class. Right? Alright. So now the next nomenclature that's commonly used is the auto-regressive system. Auto-regressive system or AR system or AR filter. I told you the nomenclature is like this. A discrete time system is also called a filter. So we call it an auto-regressive filter or auto-regressive system. And this is the system in which the output depends upon, the present output depends on the present input and previous output depend upon the present input. Please pay attention. In this system, the output depends upon the present input plus the previous outputs. But remember, it does not depend on not on previous inputs. Not on previous inputs. What do I mean by this? This means y of n will be equal to v naught x of n minus a1, sorry, not x, a1 y of n minus 1, a2 y of n minus 2 minus a3 y of n minus 3, so on. Actually, this will be minus y of an y of n minus. So this is an auto-regressive system in which the output depends upon the present input and the previous output. So you can check the previous output. This is referred as the auto-regressive system. This is referred as an auto-regressive system. This is referred as an auto-regressive system. And remember, this is a purely recursive system. This is a purely recursive system. This is also referred as a purely recursive system. This does not depend upon the previous inputs, but depends upon the present input and the past outputs. That's why this is referred as auto-regressive, meaning the next output is obtained by the, the present output is obtained by the present input plus the past inputs plus the past output, sorry, not the past input, past output. This is referred as auto-regressive system. Now the last system that we have is the auto-regressive moving averaging. Means auto-regressive moving averaging. This is also called ARMA, ARMA system or filter. Or filter. Remember, every discrete time system is also referred as a filter, right? So what's the general expression? Now the general expression of this is the same as the original difference equation. This is actually the ARMA system, means auto-regressive moving averaging system. So let me write it again. So the output y of n will be equal to b naught x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus so on b of m x of n minus m plus so minus a1 y of n minus 1 minus a2 y of n minus 2 minus a3 y of n minus 3 minus so on n y of n minus n. You can see this is actually the same difference equation. Only difference thing is we have taken this thing on the right hand side. We are arranging this on the right hand side. And this is referred as the moving averaging auto-regressive system. And why? What does the mean? What is the meaning of this moving? Because the output depends upon the present and the past inputs as well. That's why the moving term comes from this. Okay, and the averaging term comes because of these options. Right? Let me give you an example of this system. Y of n is 2x of n plus 3x of n minus 1 minus 5y of n minus 2, 4y of n minus, right? So the output depends upon the present and the past input and the previous outputs as well, right? So this is how we write the ARMA system, how we write the AR system, means auto-regressive system, and how we define the moving averaging system, how we define the moving averaging system. These are also referred as the filters. These are also referred as the filter. This we shall learn later on when we define the FIR and IIR filters. This we shall learn in class. All right. In the next session, we'll learn how do we realize these systems, how do we realize these discrete time systems in this. All right. Before I do that, please pay attention to this difference equation. Have a look at this difference equation. Write this equation 2-3 times because this is the general difference equation that's used to describe a discrete time system. So this is the general nth order difference equation which is used to describe a difference equation. All right, we already studied this in the unit 1. In the next session, we will start with the realization of these systems.